3.0.0 Installing service entrance equipment. Explain how to install service entrance equipment, identify the service drop location, describe how to select the panel board location, perform its task using an unlabeled diagram of a panel board, label the lettered components. Usually the electric service is one of the last parts installed in an electrical system, but you should plan where you'll locate this service entrance equipment from the very beginning. This section covers things you need to consider when you plan and install an electrical system. It says a service entrance equipment is the equipment that provides overcurrent protection to the feeder and service conductors. It provides a means of disconnecting the feeder from the energized service conductors and a means of measuring the energy used. Why are you not going away? 3.1.0 Locating a service drop. When laying out a residential electrical system, ask yourself the following questions. Where's the service drop? Where's the service point? Where will the power enter the building? Where will you locate the panel board? How will you get the wiring from the service entrance to the panel board? They're saying the service point is the point of connection between the facilities of the serving utility and the premises wiring. There are also other considerations, including the following. You must know where to locate the load center or panel board. That way, when roughing in the electrical wiring or installing the cable boxes and other equipment you need for the service, you know the direction and route of the circuit home runs. If there will be ungrounded systems, service laterals, you must plan for placing sleeves through footings and foundations. You might schedule a site meeting with the local power company's representative before roughing in. At this meeting, you, with the representative, will determine the size of service you need for the property. Then the power company can plan how to get a service drop to the property for the site plot plan. Caution, it says you cannot begin any work until the service side, on the service side, until the local utility company is involved. The local utility will guide your work based on the regulations of the authority having jurisdiction. So it goes on to say, according to NEC 230.9a, you must route the service drop so that the service drop conductors have a clearance of not less than 3 feet horizontally and below windows that open, doors, porches, balconies, ladders, stairs, fire escapes, or similar locations. They don't want pedestrians, they don't want people to be able to reach out of a window and touch the wires. If you're working with overhead service conductors, refer to NEC section 230.24 for the rules about vertical clearance for overhead service conductors that pass over areas like rooftops, driveways, or yards. In general, it states that they must not be readily accessible and must comply with NEC sections 230.24a through E for services not over 1,000 volts. There's usually a plot plan or a site plan for new construction. Plot plan shows the entire property with the building or buildings drawn on in their proper location on the plot of land. It also shows sidewalks, driveways, streets, and existing utilities, both overhead and underground. Figure 40 shows a plot plan for your simple residence. By consulting with the local power company, you learn that the service will come to your sample residence from a power pole across the street using triplex cable connecting to the residence at the point on its left, the west end. The uninsulated steel conductor of the triplex cable acts as both the ground dead conductor, the neutral, and the support for the insulating ungrounded conductors. It's also suitable for overhead use. So here's our little makeshift property they gave us. There's the carport, there's the utility room. This was the foyer. I believe this is the kitchen and dining room area, bedroom 1, bedroom 2, bathroom. So they're coming from across the street off of a power pole. They're going to come over to the service drop in this area. Well, we're going to have to be at least 15 feet above this street. We have to be at least 10 feet above this residential property. And doesn't look like we're going to be crossing the roof, but if we were crossing the roof, we'd have to be a minimum of, well, 8.5 feet if it's a flat roof. If it has a slope of 4 and 12, then you can reduce it to 3 feet where it crosses the roof. And if it crosses the roof less than 6 feet diagonally, 4 feet horizontally, you can reduce that again to 18 inches. Here's a highlight. It says NEC section 230.28 explains the mandatory rules for using service masts as supports. Well, let's take a look at 230.28. All right. I meant to open up to the beginning of Article 230, but here's 230.28 service masts as supports. Only power, service drop, or overhead service conductors can be permitted to be attached to service mast. Let me see, can I make this bigger for you? There you go. Service masts used for support of service drop or overhead service conductors shall be installed in accordance with A and B. Strength, the service mast shall be of adequate strength or be supported by braces or guy wires to withstand safely the strain imposed by the service drop or overhead service conductors. If you use 2-inch rigid conduit, it's plenty strong enough to withstand the strain of the cables. Hubs intended for use with the conduit that serves as the service mast shall be identified for use with service entrance equipment. And it goes on to talk about attachment. Service drop or overhead service conductor shall not be attached to a service mast between the weatherhead or the end of the conduit and a coupling where the coupling is located above the last point of securement to the building or other structure. So you need a solid piece of rigid conduit. You don't want to have a coupling in between. Take a full 10-foot stick, cut it down to whatever length you need. Make sure it's extending through that roof 3 feet. Then put your service mast, the weatherhead, on the top of it. That way you'll be 3 feet above the roof. If the roof has that 4 and 12 slope to it or greater. If it's a flat roof, again, you're going to have to be 8.5 feet up. So if you can show that there's no way a pedestrian can get on that flat roof, if it doesn't have a door that opens up to it, if it's fenced off or what have you, if there are ways that you can keep the public out of that area, you don't have to keep it at 8.5 feet. You can bring it down to the 3.5 or the 3 feet, but you have to make sure that you protect people. NEC section 230.24A covers the mandatory roof clearances for overhead service conductors, and 230.82.2 covers the meter and meter sockets permitted to be connected to the supply side of the service disconnect. All right. So coming in, this is the weatherhead. This is your clearance to the point of attachment. Where the raceway type service masts are used, all raceway fittings must be identified for use with service masts. Roof clearance plus exceptions. Here on 2. Electric meter, 3. The service disconnect, 4. 5 is to the main service or panel, goes through, and then 6 is the maximum and minimum distances per the local utility standards of how high you can have the top of that disconnect switch. (3.1.1) Vertical clearances of service drops. NEC section 230.24b specifies the distance by which service drop conductors must clear the ground. These distances vary according to the surrounding conditions. Here's a highlight. In general, service drop conductors must be always at least 10 feet above the ground or other accessible surfaces. More distance is required under most conditions. For example, if the service conductors pass over residential property and driveways or commercial property not subject to truck traffic, the conductors must be at least 15 feet above the ground. This distance may be reduced to only 12 feet when the voltage is limited to 300 volts to ground, and ours is. So, in other areas such as public streets, alleys, roads, parking areas subject to truck traffic or driveways on other than residential property, the minimum vertical distance is 18 feet. Figure 42 shows the vertical clearance of the service drop for your sample residence. So there again, if we're passing it over the street, we're going to need to be 18 feet above the street at this point. Where's 3? There you go, 3. In other areas such as public streets, alleys, roads, parking areas subject to truck traffic, driveways, or other than residential property, the minimum vertical clearance distance is 18 feet. So once we've got that, it's all downhill from there. In the residential property, I think it's 10 feet, unless it's over the driveway, then it's 12 feet. If the service conductors pass over residential property and driveways, or commercial property that's not subject to truck traffic, where the voltage does not exceed 300 volts to ground, the conductors must be at least 12 feet above the ground. This distance must be increased to 15 feet where the voltage exceeds 300 volts to ground. So over this residential driveway, it's 12 feet. If it's in the front yard, it's 10 feet. And over the roof, if it's a flat roof, it's 8.5 feet. If the roof has a slope, a rise of 4 inches and 12 inches, then you can reduce that to 3 feet above the roof. 3.1.2 service drop and overhead service conductors clearances from building openings. Here's a highlight. NEC section 230.9 states that service conductors installed as open conductors or multi-conductor cable without an overall jacket shall have a clearance of not less than 3 feet from windows designed to be opened, doors, porches, balconies, ladders, stairs, fire escapes, or similar locations. Again, it's to keep people from reaching out of a window and touching those service conductors. An exception is that conductors that run above the rooftop level of a window shall be permitted to be located less than 3 feet. They don't think anyone's going to open a window and then reach up over the window, I guess is the only thing that makes sense. For safety reasons, the 3-foot clearance applies to open conductors, but not to raceways or cable assemblies that have an overall outer jacket approved for use as a service conductor. So if it's conduit, then you don't have to keep that 3-foot clearance because you usually don't get hurt on a conduit. This requirement protects the conductors from physical damage. It also minimizes the risk that someone evacuating a building through the window might come in contact with the conductors. The exception lets you locate service conductors, including drip loops and service drop conductors, just above the window opening. In this location, they would not interfere with ladders leaning up against the structure to the left or right or below the window. So you don't need a clearance here because it's above the window. They're saying that this window doesn't open. Clearance not required for openable windows. Here's the 3 feet minimum 3-foot clearance. And they're saying here you don't need any clearance to the conduit because it's conduit, so it's safe. 3.2.0, locating the panel board. Once you know the location of the service drop, you can select the location for the panel board or load center. The panel board is the box where circuits and circuit breakers control and distribute the electrical load. A load center is a type of panel board that sometimes contains the main disconnect. Here's a highlight. It says NEC section 230.70A1 can help you identify the correct location for the panel board in your sample residence. It requires that you install a means for disconnecting service in a readily accessible location either outside or inside the building. If you locate it inside the building, it must be nearest the point of entrance of the service conductors in your sample home. The method of installing the panel board in the utility room complies with this NEC regulation, as well as the requirements in NEC sections 110.26 and 240.24. Look carefully at figure 44. It identifies the components of a panel board. You can practice labeling components of a panel board using a blank, unlabeled diagram. So here you go. Here's the unlabeled panel. So 1 is the service. Here's the service coming in. 2 is the mast. 3 is the electric meter. 4 is the main disconnect or electric. I wish this had said 125 amp weatherproof disconnect. Service ground must be connected at this point. And then 5 goes to the main service panel. You're taking it out, running it up through the utility room and down the wall to the panel inside the utility room. 6 is the overhead conductors. Let's see here. 100 amp 3 conductor with ground cable is run in finished partitions and in unfinished attic to sub panel in the utility room. Again, from our calculations earlier, I think they should have said 125 amp. This is a 100 amp panel. 8 is the equipment grounding conductor. 9 is the neutral bus. And equipment must be isolated from each other in the sub panel. After the first, the main bonding jumper. After the main bonding jumper, you never tie your ground and your neutrals together again. So here they're saying that you need to take the equipment grounding conductor to the grounding bus bar, and all of the neutrals go to the neutral bus bar, and these are not tied together. All of the grounds come down here to the grounding bus bar. None of them are going up here anymore. Equipment grounding conductors, that's 10. Note that NEC section 230.85 requires an outdoor emergency disconnect on all 1 and 2 family dwelling unit services. An alternate method utilizes conduit from the meter base routed under the concrete slab and then up to a main panel board located in the utility room. NEC section 230.6 considers conductors to be outside of a building when they're installed under not less than 2 inches of concrete beneath the building, or installed in conduit under not less than 18 inches of earth beneath the building. Sample residence has a 4-inch reinforced concrete slab well within the NEC regulations. Section 3.0.0 review. According to NEC section 230.24b, if 122.240 services conductors pass over residential property and driveways or commercial property that's not subject to truck traffic, where the voltage does not exceed 300 volts to ground, the conductors must be at least how many feet above the ground? And according to NEC section 230.70a1, if you locate a means for disconnecting service inside a building, it must be, all right, I'll let you answer those. I'll go on to the next section. .0.0 residential wiring methods. Identify wiring methods for various types of residences. Explain how to select and install cable systems. Explain how to select and install raceways. There are no performance tests for this section. In residential construction, you install branch circuits and feeders to provide power wiring. Wiring installations may be open or concealed. You use open wiring when the appearance of wiring will not affect the appearance of the residence. You install the cable and or raceways in places where they can be seen and accessed, such as the surface of walls, ceilings, and columns. You'll find open wiring in areas such as unfinished basements, attics, and garages. In general, you'll find the following 2 basic wiring methods in most modern residential electrical systems. Sheath cable of 2 or more conductors, that's the non-metallic sheath cable, and raceway conduit systems. How do you know which method to use? You consider the following factors: the NEC requirements, local requirements, the type of building construction, the location of wiring in the building. Most of the time, you can use either of the 2 methods. You can even use them both in combination. 4.1.0 cable tray systems, or cable system, excuse me. You can choose from the following types of cable for wiring systems to feed or supply power to equipment: non-metallic sheath cable, metal clad cable, underground feeder cable, or service entrance cable. Using non-metallic sheath cable, 4.1.1. Non-metallic sheath cable types NM and NMC, is manufactured in 2, 3, or 4 wire configurations with varying sizes of conductors. See Article 334 for requirements, installation information, and construction specifications. In cables, conductors are color-coded. The cable also includes a grounding conductor, which is usually bare or green. So in 2-wire cables, one conductor is black, the other is white, and then the ground is bare. In 3-wire cable, one conductor is black, one conductor is white, the third is red. Type NM and NMC are basically the same. One difference is that type NMC has a corrosion-resistant outer non-metallic sheath. It has a jacket or covering made of rubber, plastic, or fiber. Jacket markings for type NM cable typically provide the manufacturer's name or trademark, the wire size, and the number of conductors as shown in Figure 46. So it says non-metallic. This is 12-2, so it's 12 gauge conductors. There are 2 of them with ground. The ground is bare. Type NM cable must be secured or approved by approved staples or straps at intervals not exceeding 4.5 feet within 12 inches of every outlet box, junction box, cabinet, or fitting. If it's a plastic box, you have to be within 8 inches of that plastic box. 1 and 2 family dwelling units are attached or detached garages or storage buildings. Multifamily dwellings, when they're of types 3, 4, 5 construction, see the informative Annex E. Other structures, if concealed behind a 15-minute thermal finish barrier and are of types 3, 4, or 5 construction. NEC section 334.10a specifies when you're permitted to use type NM cable for both exposed and concealed work in normally dry locations to be fished into the voids of masonry blocks or tiles. NEC section 334.10b specifies when you're permitted to use type NMC cable for both exposed and concealed work in dry, moist, or damp or corrosive locations and outside and inside walls of masonry block or tile. Here's a highlight: in a shallow chase in masonry, concrete, or adobe protected against nails or screws by a steel plate at least 1/16 inch thick and covered with plaster, adobe, or similar finish. NEC section 334.12 prohibits the use of type NM and NMC cable in the following applications. In any dwelling or structure not specifically permitted in NEC section 334.10 as open runs in dropped or suspended ceilings in other than 1 or 2 family or multifamily dwellings as service entrance cable, in commercial garages with hazardous load areas, in theaters and similar locations except as permitted by section 518.4c, in motion picture studios, in storage battery rooms, in hoistways or on elevators or escalators, embedded in poured cement, concrete, or aggregate, or in hazardous areas. Here's a highlight. It says, in addition, type NM cable is prohibited in the following areas. And here's a highlight. It says, in the shallow chase in masonry, concrete, or adobe, and covered with plaster, adobe, or a similar finish. You can do NMC, not NM. In wet or damp locations, embedded in masonry, where exposed to corrosive fumes or vapors. Type NM cable is the most common type of cable for residential use. Figure 47 shows additional NEC regulations pertaining to the installation of type NM cable. So, I'll let you read these in your book. There's a lot of really good information in these. Make sure you read all of these. 4.1.2, using metal-clad cable. Metal-clad type MC cable is manufactured in 2, 3, and 4 wire assemblies with varying sizes of conductors and is used in locations similar to those for type NM and NMC. Unlike type NM and NMC, it can also be used as service entrance cable and in other locations permitted by section 330.10. The metallic spiral covering on type MC cable offers a greater degree of mechanical protection than type NM cable. Type MC cable may be embedded in plaster, finish, brick, or other masonry except in damp or wet locations. It may also be run in the air voids of masonry block or tile walls except where such walls are exposed or subject to excessive moisture or dampness. May be used in wet locations if the conditions of NEC section 330.10A11 are met. Figure 49, this is a highlighted, says it may not be used where subject to physical damage. So here's your staples, here's your two-hole straps, here's a chase or a connector, and here's a 90-degree connector. This is a straight connector. You might have to use running boards. Guard strips at least as high as the cable must be provided. This is up in attics, covering the installation of type MC cable. Metallic spiral covering on MC cable. Make sure you don't bend the radius. 7 times the diameter equals the allowable radius for interlocked armor or corrugated sheath, depending on the type. Section 330.24b. 4.1.3, using underground feeder cables. Another type of cable is called underground feeder. Type UF cable resembles type NM cable. However, the jacket is constructed of weather-resistant material to provide the required protection for direct burial wiring installations. According to NEC Article 340, you may use type UF underground, including burying it directly in the earth as a feeder or branch circuit cable if it has overcurrent protection at the rated ampacity as required by the NEC. When you use type UF cable above grade and where it will come into direct contact with the rays of the sun, its outer covering must be sunlight resistant. Where type UF cable emerges from the ground, you must also provide some means of mechanical protection against physical damage. This protection must be in the form of conduit or guard strips. NEC section 300.5D1 requires that the protection extend from the minimum burial depth below grade to a point at least 8 feet above grade. NEC section 300.5D4 states that if you use conduit as protection, the permitted types are EMT, RMC, IMC, RTRC, and Schedule 80 PVC, or the equivalent. .4 using service entrance cable. NEC Articles 230 and 338 specify how you must install service entrance and underground service entrance cable for electrical services. Remember, this is type SE and type USE, not U's. Type SE cable is available with the grounded conductor bare for outside service conductors and also with an insulated grounded conductor for interior wiring systems. Here's a highlight figure 50 using service entrance cable. And here's your bare neutral. I'm sorry, that's the, well, they're showing this. This is supposed to be a black and a red, and this is the bare neutral. Or if you have a neutral, you have a black, red. The neutral is insulated, and then you have the ground, which is also insulated. Type SE cables available with the grounded conductor bare for outside service conductors and also with an insulated grounded conductor for interior wiring systems. When used for branch circuits and feeders, all conductors in the Type SE cable shall be insulated, with the exception of the equipment grounding conductor. Type SE cable must follow the rules of Type NM cable installation, NEC section 334 part 2, except for determining ampacity when installed as an interior wiring system. With exterior installations, the cable supports must meet the requirements of NEC Article 224 as well as NEC Article 225 or NEC Article 230, depending on the type of circuit being installed. Let's see, when installed as exterior wiring, the requirements for NEC Article 225 must be met. That's outdoor branch circuits. With the support of the cable in accordance with section 334.30, type SE style R cable may be used in residential applications in certain conditions, such as subfeeders for ranges. So here's NEC sections governing type SE cable. Here's the weatherhead, here's the mast. It says type SE cable, when used as service entrance conductors, must be secured every 30 inches and within 12 inches of each termination point. That means that they're not even in a conduit, they're just stapling it or strapping it to the side of the house. 2 cable bends shall be made so that the cable covering is not damaged and the radius of the bend is not less than 5 times the diameter of the cable. There's 2. There's 2. All right. Use type SE cable for interior wiring, NEC 338.10b4. Closed drywall of an electric range. And all branch circuits and feeders must have an insulated neutral, NEC section 338.10b2. 4.2.0 raceways. A raceway is any channel designed and used solely for the purpose of holding wires, cables, or bus bars. Types of raceways include rigid metal conduit, intermediate metal conduit, rigid non-metallic conduit, flexible metallic conduit, electrical metallic tubing, and auxiliary gutters. Raceways are constructed either of metal or insulating materials such as polyvinyl chloride. Metal raceways are joined using threaded compression or set screw couplings. Non-metallic raceways are joined using cement-coated couplings. Where a raceway terminates in an outlet box, junction box, or other enclosure, an approved connector must be used. Let's see, raceways provide mechanical protection for the conductors that run in them and prevent accidental damage to insulation and the conduit material. They also protect conductors from corrosive atmospheres and prevent fire hazards to life and property by confining arcs and flames that may occur due to faults in the wiring system. Conduits or raceways are used in residential applications for service masts, underground wiring embedded in concrete, and sometimes in unfinished basements, shops, or garage areas. All right. 4.0.0 section review and 3-wire type NM cable. The color code of the conductors is what? And which of the following areas of a residence would not likely use conductors running conduit? Okay. Okay. I'm going to end the video here, and I'll see you on the next, I guess it's part 5, no, part 4. I've lost track. I think it's part 5.